G'day guys, how's it going? So in this video, we're going to take a quick look at constant functions in Rust and the type of functions that we can write and how they can be useful in basically creating constants that are more optimized for runtime. So basically, let's do something like this where we'll have a function and I'll call it days to seconds, all right? Now, I'm going to set this as an unsigned 32 and it will return, say, an unsigned 64, right? Because the number of seconds is always going to be higher than the number of days. So what I'm going to first do is I'm going to go, I want the number of days times the number of hours in each day times the number of minutes in each hour times the number of seconds in each minute, right? Now, it's probably going to complain because I'm not returning. Oh, no, it's okay. So it's worked out. It needs to return an unsigned 64. And this is a function that you would see normally, right? So you might come down to here, and then you'll say something like, let 10 days as seconds equals days to seconds, and you'll type 10, and then you may print this out, right? So you'll do something like this. And I forgot the exclamation mark, and we'll go 10 days as seconds, right? So I'm actually going to run this at the command line at the moment, and I'll explain in a minute why I'm doing that. But if I just do a build of this, it's going to crash. Why is it crashing? I was returning unsigned 64. Oh, yeah, it is complaining about the fact that it needs to be U64. And in fact, I'm going to need to do that for all of these. That's fine. We'll just quickly do that, and that should work again. So if I compile it this time, it shouldn't be an error. Cool. So it compiles really quickly, right? Because this code isn't executing at compile time, it's executing at runtime. Now, this is not going to be that slow anyway. So when I actually run this for real, so if I go cargo run release, it basically prints it out straight away, right? Now, let's just pretend for a moment this is a slow working function. In order to get this to execute at compile time, we need to make this a constant variable. So we can do something like this. Const 10 days as seconds. And this all has to be uppercase. So that's why I'm just doing this. Equals days to seconds, 10, right? And then we can print that out. Now, if I run this at the moment, we're going to get an issue, and that's because, well, first I need to define the return type, which I didn't do. Silly me. But if I run it again, right? Yeah, if I try to run it again, it's going to complain because this is not a deemed a constant, right? A constant expression. This is non-constant. And it's non-constant because it's not denoted with the word const at the front. So once we add that in, this now becomes a constant function. And if I run it this time, the code will execute as it did before. So what's happening here is we're now executing this function at compile time, and we're assigning the value of this call to this constant. And then basically we're using this constant throughout our program. So if we pretend this is a really slow running function, then this could be beneficial as it's evaluated at compile time, and then this would be instantaneous the minute the application runs. So let's see another example. Let's actually generate something that might be a little bit slower. And I'll explain in a minute why it doesn't quite work out the way I anticipated it to. In fact, I'm just going to copy and paste the function here to save time. So this slow code is basically doing a while loop, it's doing 10,000 iterations, and then it's doing a secondary while loop where it's doing 500 more, and then it's incrementing I on the first iteration of this second loop, and then it's iterating J. So this is just a delay tactic to increment I, right, to 10,000. So this works when executing as a constant function, and other approaches that you may have seen, like making it sleep and all that. That's all runtime stuff, so we can't use that here. So instead, I've introduced a second while loop to try and create a delay. Cool. So if I now come in, instead of executing this immediately as a constant, if I come in and say let result equal, and then we'll call slow code, and then print out the result of slow code. If I now run this immediately, well, it's going to compile quickly and it's going to spit it out quickly. Now, let's just pretend for a second that this is a larger number. So let's go a few more zeros on each one. And we'll run it again. And now it's starting to run, and it's going to take a little bit of time, right? So this could take quite a few seconds. In fact, it's still running. So what I'll do is I'll pause the video and I'll come back in a moment. Okay, I had to stop it. It was just taking a little too long. But I think you understand that this is really slow operation that is executing at runtime. And if we can basically take this same operation and do it at compile time, then when the code runs at runtime, then it will be instantaneous. That's the idea, right? So let's just reduce the numbers here, and I'll explain why in a minute. So I'm going to come back to this and just make sure I can rerun it. And it's quick. Yep, so it's quick here. Now, if I decide instead of using a variable and I convert this now to a constant, so we go const, and we'll just say result equals result of, was it U32 equals slow code. If I now decide to print this out, instead of doing the following up here, and this time I just do a compilation, not a run. So we'll do a cargo build -- release. You can see it takes a little while to compile, and then it comes up with an error, right? Now, what it's telling me here is that it's warning me that this is a long-running const evaluation, and this may be what you want. This may not be what you want. For the purpose of this example, it is what I want. So what I'm going to do is I'm going to add a flag at the top of the file to allow this to happen. So I'm going to allow long-running constant evaluations. And then I'll run this again. And now it's going to spend probably the next few seconds building. It's even going to tell us, and there it is, it's finished, right? Within 5 seconds. But it did warn to us that this is taking a while to run, right? Cool. Now, if I go ahead and I go through the process of just running this now, you can see the value is also instantaneous. Now, this is not a great example, and the reason why it's not a great example, and I'm still trying to work this out, is that the Rust compiler is a lot slower evaluating Rust functions than the Rust or the actual executable on your machine, like the Linux kernel and stuff. I'm not sure how to optimize it at this stage. I'm still going through that process. But basically, my understanding is the Rust compiler is using a limited number of cores to evaluate your constant functions. And when you've got long delayed ones like this, it just takes a lot longer to complete, which it makes it difficult to kind of illustrate a slow operating function on at least this machine. So I'm using a virtual machine. Maybe it makes a little bit more sense on your machine. I don't know. But essentially, that is the idea, right? You create a function that's slow. You define it as a const. You can assign it to a const result, and then you can use that throughout your code. rather than, having all of this execute at runtime and then say I passed in result a number of times. So I could do this, right? And if I was to build this, it'll take another 5 seconds at compile time, right? But at runtime, it'll still be instantaneous, right? So the idea is that result will be defined once, and then wherever it's using the program, it'll just have a hard-coded value here that's already predetermined at compilation time. Cool. Now, just one last thing I'll point out quickly is you can do some form of validation in constant functions. So let's say that this days to seconds function doesn't allow days less than or equal to 0. So we could say if days equals 0, and then we could say panic, right? Days must be higher than 0. Cool. And by doing this, right, if I now come in and I try to compile actually, before I do that, I need to come down and set, where's the constant? Here. So let's now set this to 0. All right, so this shouldn't work. If I now come through and I try to compile the code, it's going to throw an error immediately at compilation time, because it's going to say array is constant encountered. So it's essentially telling us that it couldn't evaluate that constant, because when it tries to evaluate it by calling this function, 0 is not valid, and therefore it breaks, right? So that's another thing you can do. I can change this to, say, -1, like so, and I'm going to get the same error. In fact, what happened there? Here's the second -1. Cannot apply unitary operator. Oh, interesting. I was just trying to type -1. Interesting. You can tell I didn't do this ahead of time. So basically, it's not allowing me to use negative numbers. Interesting. I could do something like this, though. 0 minus 1. That would give us -1. And there's the error again. Or I could do 0 plus 1. So 0 plus 1, right? And that will compile. It'll take 5 seconds, but it compiles. It warns us that it's slow. And then when I actually run it, Bob's your uncle. Cool. So that's another way that you can create basically constant expressions for constant values, especially if you're trying to deal with code that may be slow that you can evaluate at compile time. So that's where I'm going to end this video, and I'll see you all in the next one.